Good morning, everyone. Myself, Dr. Amanathulla, Assistant Professor, Department of Mathematics, Raghunathpur College, Purulia, West Bengal. Today, I will teach about coloring of graphs and its applications. You know, mathematics is divided into two important branches. One is pure mathematics and another is applied mathematics. One of the important part of applied mathematics is graph theory. And graph coloring is a key topic in the field of graph theory. What is graph? What is graph? And what is the origin of the graph? The origin of graph is Königsberg bridge problem. What is the problem? Here the problem was there are 4 land areas X, Y, Z, and W. And there are 7 bridges, 1, 2, and 7. There are 7 bridges are there. Here the problem was, is it possible to move starting from any one of the land area and back to that land area by using every bridge exactly one without swimming or crossing the river? Euler proved that this type of movement is not possible by designing graph. He took 4 vertices, 4 land areas at the 4 vertices of the graph, X, Y, Z, and W, and join these 2 vertices if there is a bridge. Here we see that X and Y, there is a bridge. So the vertex X and Y are joined by an edge, that is by a line segment. Here X and W, there are 2 bridges. So there are 2 edges between X and W, 1 and 2. These are 2 edges. In such way, this graph is designed. And Euler proved that such type of movement is possible only if all the vertices is of even degree. Here the vertices is several vertices are there of odd degree. So this type of movement is not possible. By solving this problem, the graph theory was invented by Euler. What is the formal definition of graph? Graph is nothing but the ordered pair of vertices and edges, V and E. Here, the heavy dots represent the vertices of the graph, and the line segment between these 2 vertices are called the edges of the graph. What is the degree of the vertex? The degree of the vertex means the number of edges joined to that vertices with self loop counted twice. What is self loop? In general, for an edge, the 2 vertices are distinct. For that edge between X and V, the n vertices X and V are distinct vertex. But if there is a same vertex, starting and ending vertex is same, then this edge is called self loop. Here in the vertex Z, there is a self loop. For that self loop, the degree counted twice. So here for the vertex X, the degree of the vertex is 4 because there are 4 edges are incident to that vertex. But here for the vertex Z, the degree of the vertex is also 4 because 2 edges are there and one self loop, it counted twice. So the degree of that vertex is also 4. What is walk? Walk is nothing but the finite alternating sequence of vertices and edges. These are the walk. Euler solved this problem by an well-known theorem, which we already stated earlier. This type of movement is possible if the degree of every vertex is even. What is graph coloring? Graph coloring is an assignment of colors to the vertices of a graph in such a way that any two adjacent vertices have different colors. And such type of problem, our aim is to minimize the number of colors. And using minimum number of colors, we have to color that graph completely. This is our problem. This is a 4-color theorem. It's an important theorem in graph theory, very famous theorem. It states that any planar graph can be colored by using only 4 colors. Here, this is the graph of India, and here we see that the number of colors are more than 4. But if we want to color that graph so that two adjacent province or adjacent states have the different colors, we can color that graph by using only 4 colors. Here, the graph of India is colored by only 4 colors. These are the 4 colors. Here we consider a problem, real life problem, examination scheduling problem, and solve this problem by using the technique of graph theory, especially the graph coloring. What is the problem? This problem also we can use the examination scheduling in NEP schedule of NEP 2020 syllabus also. What is the problem? There are 8 groups of subjects. First one is mathematics, physics, chemistry. Second one is biology, English, computer science, and so on. There are 7 subjects are there: mathematics, physics, chemistry, biology, English, computer science, psychology. Here the problem was if the university wants to take a semester examination, we are going to find out that what is the least number of slots. What is the least number of slots required to conduct the examinations, and also find out the slots. This problem can be solved by graph coloring. How? First, we take 7 vertices as the 7 subject as the 7 vertices of the graph. M for mathematics, P for physics, C for chemistry, E for English, and so on. And if two subjects are in the same group, then there is an edge between these 2 subjects. Here we see that mathematics and physics in the same group. So there will be an edge between mathematics and physics. Mathematics and chemistry is also in same group. Mathematics and computer science is also in the same group. Mathematics and biology, mathematics and psychology are all in the same group. So we join mathematics and physics, mathematics, chemistry, mathematics, psychology, mathematics, computer science, mathematics, biology, mathematics, physics and chemistry, and so on. These are the graph. Then we label or color this graph by coloring. Here, for mathematics, we can take any color. Suppose the color of mathematics M is red. Then since this is red color, and mathematics and physics, mathematics and chemistry are the adjacent nodes or adjacent vertices, so we cannot take the color of the vertex P or C or B by red, but we can take the color of the vertex E as red, because there is no edge between M and E. So these 2 vertices are not adjacent to each other. So we can take this vertex as red color, and then physics by blue, and in such a way the coloring process is completed. Here we see that there are only 4 colors are used. So the number of examination slots is only 4. And the slots are mathematics, English is 1 slot, physics, biology is 1 slot, chemistry, computer science, and psychology. These are some references. Thank you. Thanks.